Hopefully you've already watched my first two videos and have developed an appetite for heresy. Physicists are very religious people who cannot abide criticism of their beliefs, so I have no doubt that what I have said in those videos will lead to me being vehemently suspected of heresy. However, if we consider the effect that a moving observer overestimating force has on the most basic experiment in electrodynamics, the heresy dial goes completely off the scale. Let us assume that a stationary observer measures the force between two stationary test electrons as F. By the principle of relativity, an observer moving alongside two such test electrons all going through space at v must also measure the force to be F. However, a moving observer overestimates force by a factor of 1 over the square root of 1 minus v squared, so the force must really be only F times the square root of 1 minus v squared. If all you ever knew was only relativity, then doubtless you would assume that the electric force between comoving test electrons reduces by a factor of the square root of 1 minus v squared. But if you have been taught basic electromagnetism, you will likely find such a suggestion utterly abhorrent, and insist that what is really happening is that the electric force remains at 1 due to charge invariance, but a secondary attractive magnetic force of 1 minus the square root of 1 minus v squared appears, which partially cancels out the repulsive electric force. My defense to this charge of heresy is to point out that by explaining away the so-called magnetic force in terms of electric forces, all I have really done is what Purcell tried to do 60 years ago. I would also point to Feynman's quote in the Feynman Lectures on Physics: "One part of the force between moving charges we call the magnetic force. It is really one aspect of an electrical effect." This force between commoving electrons presents further problems for special relativity believers because they have a doctrine that an electric force in one reference frame is a magnetic force in another reference frame. If we assume that the electric force between commoving test electrons reduces by a factor of the square root of 1 minus v squared, then there is no magnetic force in either reference frame. On the other hand, if we stick with charge invariance and assume a magnetic force of 1 minus the square root of 1 minus v squared in our rest frame, this force of 1 minus the square root of 1 minus v squared does not appear in the moving frame, as the moving observer just measures the force to be 1. But there is more and worse heresy to come because physicists have another ubiquitous doctrine, that Maxwell's equations are consistent with special relativity. However, if special relativity agrees with experiment, it must predict that you get a greater force on a test electron if you move a current-carrying wire past a stationary test electron than if you move a test electron along a current-carrying wire. And I do not think Maxwell's equations do predict that, which means that either special relativity does not agree with experiment, or else Maxwell's equations are not consistent with special relativity. If physicists were the rational scientific minds they claim to be, then surely they would throw their hands in the air and declare the emperor has no clothes. But in general, physicists as every bit as religious as members of any other religion, so doubtless they will declare this video a heresy and continue to believe the same nonsense they always have. These videos have barely scratched the surface of the link between so-called magnetic forces and the principle of relativity. So, if you want to know more, buy my book before it gets banned.